Hello, this is Mr. Huff. Let's take a look at this. So the first thing we want to do is make sure that you draw this diagram. So this is for notes. Put this in your notebook, get it on a piece of paper. You will need this for reference. If you don't have this map of what the points are, then it's going to be impossible to do the problems. So first draw a triangle, draw a straight up and down line about halfway through it, put a point right there and connect these corners to that. Then we're going to label this diagram. So we're going to lay this on the ground out with the points of a compass. So we'll have this little guy over here is at north. This will be the angle N. And then E is east and S is south. Okay, so this little guy's at the south end, this guy's at the north end, the rocket is down here at the east end. The distance between north and south, we're going to call that the baseline. It's a length. And right here, we're going to have a rocket launch, and it could be from anywhere, but when we measure the apogee, this is going to be point A, the apogee, and directly straight down below that will be our point on the ground. We'll call it point G, and it's going to be east of the north and south line. Whenever it reaches the apogee, this guy is going to measure the elevation angle. We're going to call this angle B, the elevation angle from the north, and angle C is going to be the elevation angle from the south. So we have N for north, S for south, little b for baseline, big B for elevation angle from the north side, big C for elevation angle at the south side, point A is apogee, and point G is the point on the ground directly below the rocket. So make sure you have this drawn in your notes. I'll also share this document, but it's going to have a little discussion about what each one is. Oh yes, let's talk about the east angle. Since there's 180 degrees in a triangle, you will be given the north and south azimuth values, and you just take 180 minus north plus south, and that will tell you the angle of this east. So when we're talking about azimuth, imagine a plane that's flat on the ground, and we have this straight line between these two, and it's the angle from this person to this point measured here, and from this person to this point measured here. Okay, hopefully that's helpful. So let's just review what each letter means. We'll have an angle N. This is the north azimuth. Angle S, the south azimuth. Angle east is the sum of north and south from 180 degrees. Angle B is the elevation from the north observation. Angle C is the elevation from the south observer. Point A is the apogee that the rocket reaches. Point G is a point directly below the apogee. And distance B, this is the length of the baseline. So it's important that you understand what all of those mean in relation to this diagram. Let's look at the formulas. So copy these down. So whenever we say GA, we mean the line connecting G to A. I could also put altitude there. So we will have two different calculations possible, one from the north observer and one from the south observer. So to calculate the altitude from the north observer is the line between G and A is equal to the sine of the azimuth measured by the south observer times the tangent of the elevation angle measured by the north observer times the baseline length, which is also divided by sine of E, or the east angle. To calculate the altitude from the south observer, you're going to measure the line from G to A. It's going to be equal to the sine of the azimuth made measurement by the north observer times the tangent of C, which is the elevation angle measured by the south observer, times the baseline divided by the sine of the east angle. And then you're going to calculate the average altitude by adding those two values together, the north observation and the south observation, and divide it by 2. To calculate our plus or minus error percent, you're going to take 100 times the difference between the north observation and the south observation, divided by 2 times the average altitude. And this is basically setting up a boundary that says the average is in here and it's plus or minus some percent. So the lower that percentage, the more accurate our angle, or not our angle, the more accurate our altitude measurements. So if they were exactly the same, we would have a 0% error. And then the further apart they get, the higher that percentage error. So for the calculations you will be doing, enter the absolute value, which will be the positive number that you get. So if you get a negative number on your calculator, drop the negative and enter only the absolute value, because this is stated as plus or minus to establish a window around the average value. All right. Let's look at an example. First, you're going to write down your givens from the problem. So it might have something like this, where you have a north azimuth made by an observer and the elevation angle made by the observer at the north. Again, the south observer is going to record a southern azimuth, and the south observer might include an elevation angle, and then the baseline between them would be 250 or 200 feet. And then we can calculate the east angle based off of the north azimuth and the south azimuth, so that's 110 degrees. So you can look at this as an example. We're going to do a lot in this example. You're going to find both observations. We're going to calculate the average and then the error percent. We'll be using the formulas you've already written down, and here we go. The substitution for the north observer, I'm going to make these bigger. So it's going to be sine. You would just plug it in your calculator like this. I'm not going to read this off. I don't find that to be useful. Take a look at it. Make sure you understand where I'm getting these numbers and how they relate between the formula and the list given to you in the problem. And then let's make this a little bigger. So we calculate the north observer altitude and the south observer altitude. Then we find the average. So we find an average of 157.4 feet. And we calculate that error percent. So remember to show, when you plug this into Canvas, put only in the 3.52. If it's negative, just put in 3.52. All right, and I always like 4 significant figures. On error percent, but put in the 4 significant figures just for good measure to make sure your answers are correct. And then finally, here are all of my solutions. Let's make this a little bigger and scroll down. Okay, so there's our north observation, our south observation, the average, and the error percentage. I won't ask you to do all of this at once. You're going to do each of these individually in your practice problems. You'll calculate altitudes and error percentages first, the averages, and then you'll calculate either the north or the south observations. All right, that's all you need to know to do this kind of measurement. And again, the most important thing is this diagram. Make sure you have these notes before you start trying to calculate these problems.